I'm talking about the generative AI, but this topic is really, really big that I am just covering the large language model side of generative AI. My name is Lee Park. I'm a PhD candidate in statistics. I'm also a graduate research assistant at it's called PADS Up at the University of Kentucky. Good. I'm going to be a data scientist at Travelers starting like February. I've been with them like past 2 years, working on the large language models in insurance field. Okay, here's agenda. You can just read through. I'm not gonna just name it like everything, but we just gonna talk about large language models. Okay, so we're gonna go through the definition of large language models, but when I see the word, the name large language models, each pieces has meanings. Okay, so first, models. When I see the word model means a function. So what does a function mean? Function takes an input and it spit out output. So in this context, the model needs an input. Without an input, it doesn't generate output. Okay. The next one is language. So language means this particular model takes an input in text format. Okay, so that's why it's called language model. Then what does it mean large? So that's the tricky part. The definition of large has changed the past 2 years so much that, as an example, BERT back in 2021 with 100 million parameters considered as like a large language model, but now it's like tiny minuscule language model. Okay, so it has changed in past years so fast. Okay, so I'll go through some like example use cases, and I'll use this slide over and over as I explain some like a basic architecture of the model later. So the first use case would be sentiment analysis. So you provide a movie review to the model in text format, then they give you the score of the review in scale of 1 to 10. And the second use case is translation. You give one language, then they spit out the translation in another language. Last one is the most common use cases. It's question answering. You give the prompt, which is your question to the model, and then they give you the response. Good? Any question? So I'll go through some like a common beginner's questions, and by answering those questions, I'll introduce some like common terminologies in large language models. So the first question is like, okay, I said it's a function, but back in high school, you learned a function is all about numbers. You give the number into the function, you get the number out as an output, right? I said it's a function, but the input is a text. So where is the link between the number and text? So that's where tokenization comes in. So tokenization basically transform text into number. So I'm not a computer science guy, but I see like a hash map is something like a dictionary in Python, right? So there's a big dictionary object, or just imagine there's a big dictionary object where the keys are like pieces, like subwords in like English, and values are just like a token IDs. So you're assigning like a unique numbers to each of the like words. So in this example, the word the gets the ID number 342 and so on. Good. So tokenization means you split the text into sub pieces and you find the ID of those sub pieces in your hash map or dictionary object. Good. And we call this tokenizer. So far so good. And this number goes into the function. That's why it's a model. Good. The next one, model structure. Have you heard about encoder-decoder structure? Encoder model, decoder model, encoder-decoder model. What are those? Okay, you can just read it over. I'll just give you an example. I read Frankenstein like back in like high school. I'm not a book guy. I go to the book club, but you guys know me. Like I don't really read the chapters, but I just go there for pizza and beer. But anyway, so the very first book I read in high school was Frankenstein, and I was shocked that the plot was very different from the like animations and like movies. So I totally forgot about the story, and my girlfriend, like a week ago, asked me about like, hey, did you know like a Frankenstein had like a different plot? And then like, okay, let's say that. Let's say somebody asked me like, what is a Frankenstein plot? What's happening in your brain, right? When you hear that question, there's something you haven't spoken yet, but something is working there, right? Your brain try to like summarize all your knowledge in one little like thing in your brain, right? That's what encoder does. Like when you get the prompt, you try to get the context of the question as well as you plan out what you're gonna say, and all those things goes into the output of encoder. So encoder is like summarizing and try to summarize those context into sequence of numbers called vectors. Okay. Decoder, on the other hand, is based on all the provided information. They try to generate the next word one by one. So decoder is generation part. So when people say generative AI, it's mostly talking about decoder side. ChatGPT, yes.
So the encoder is not making any decisions? It's only basically a smart tokenizer?
It's not a tokenizer, but okay, that's a good question. Let me go into a deeper side of this talk. But okay, so encoder is basically used for, okay, let's go to example here. So you see the sentiment analysis, they read the movie reviews, and they just giving the output in number format. It's not generating anything, right? So in this case, yes, translating into the vector, and then you add like a few more like a neural network layers, and then you get the prediction. So in this case, you don't need a decoder because you're not generating anything, but you just need encoder and their summarization and predict the value. But let's take a look at the second one, translation, right? But in this case, you get the information. Based on the information and context, you have to generate things in another language. In this case, there are two options. What is the option? You keep both encoder and decoder, or you just keep the decoder. And there was a paper published like early this year or like early last year. I don't remember the year, but the paper showed that decoder alone is enough in such task. So GPT, if you had studies in like a large language models, then you probably remember the model T5 and Roberta, and there used to be like encoder decoder models back in the days, but you barely see like a new models adopting this encoder decoder architecture because it has been shown that decoder only model capable of doing the task that encoder decoder model does. So, and they're generally can be better than them. And another advantage of just like adopting decoder only architecture is that you save the size of the model. You don't need the parameters in the encoder side. So, did I answer your question?
I'm going to have to hear this plenty of times.
Okay.
Thank you.
Yeah.
You basically explained.
Okay. So encoder, it's basically summarizing and try to transform the text and context into numbers. And decoder, it generates. All right? So the last question is about embedding. So you also hear about embedding if you heard about like a RAG, which is pretty much popular terminology in large language model. But embedding in general means transformation of an input into a vector. So going back to the architecture, you see the embedding in the bottom of it. So what happens after you tokenize a text is that they transform one single number into a vector. That's what embedding does. Then what does an encoder do again then? Encoder is a large embedding layers. You can think of it that way, right? So encoder at the end embed each of the subwords after tokenization, as well as one more vector that summarizes the context of the entire text you provided. Good? So in this example, the encoder will generate 5 different vectors, one for each of the word and one for summarizing all the context. Okay? Okay, then contextual embedding is the single vector that summarizes the entire context of the text. And people just call it embedding. So when people say embedding, it means contextual embedding out of encoder. Good? All right. The next question, it's not a technical question, but people always ask, do I really need a big and complex model like a ChatGPT or let's say Palm or Anthropic or something like that? Do I always need that? It really depends on the scope of the project and how much data you have. It really depends on like what you want to do with it. If you're doing like a simple task, you don't really need it. Maybe like language models back in 1990s can handle like many of the simple tasks. So model size, if you're doing like a complex thing, yeah, go ahead and spend money on OpenAI stuff, but like it's not necessary. Fine-tuning is a terminology we use for customization. So if you have like a very narrow use cases, and if you have like your own data set where you want to shift the knowledge of language model to that, then you're customizing, and we call it fine-tuning. Okay? And the questions are always like, should I customize a model for specific use cases? I'll answer this question when we address the topic on retrieval augmented generation. So before we move on to the life cycle of AI project, I just want to give you some like what it is like to be a doctor or a lawyer, even though I'm not either of them. But okay, so and then I'll introduce the terminologies by comparing like each of the steps to be a doctor or something. So the very first step is like you have to go through high school and college and you learn some like a general knowledge, right? So that is comparable to pre-training step of large language models. They learn a lot of stuff from Wikipedia, book corpus, and many different texts, and they just get some knowledge and just get the probability of predicting the next word or something like that, okay? Then the step 2 is after they graduate the college, they take some like specific exams, they go to med school or law school and learn domain specific knowledge. And this step is called fine tuning. And so the task for exam taking is like getting the right answer of the multiple choice and writing good essay or something like that. So it's a task specific. And it's also domain specific. So it's called fine-tuning, customization. And then after they graduate and get some credentials and stuff, they go through the first entry position, and throughout that, they get some feedback from colleagues, and they get some feedback from boss. I can say that's comparable to reinforcement learning from human feedback. So even though you learn stuff in the step 2, you get preferences of others and you tune yourself into that. Then lastly, you become a professional. That's the step for deployment and use of a model. Good? So here is the flow chart I got from Deep Learning AI. As you see, you first get the scope of the project, then you select the model and adapt and align model, and then you just use it and just keep making better. But I really want to highlight that the very first step is so important that when you make a bad decision in the first step, everything else is going to be really bad. Okay, so I answered the very one of the questions was asking like, do I always need a complex model? That question is very important to ask like over and over, even along the way. Okay, let's focus on the adapt and align model section there. So I'll go through what is prompt engineering, fine tuning, and align with human feedback. Then I'll introduce the RAG. Okay, prompt engineering and tuning. This side is basically focusing on input or prompt. So they try to make better prompt, thinking that garbage in, garbage out. So you don't want to give garbage to the model because it's going to spit out garbage. So you want to make your input better to get the better result, right? And when people say prompt engineering, it means manual trial and error. So they manually try different prompt to see like what prompt to make you get better output.
Isn't the prompt engineering basically human feedback, but in a slightly different way? In other words, it's human forcing input to achieve a particular output, but it's not human feedback, and that human feedback is modifying probably the neural network layers and that kind of stuff. Here, you're not modifying those, you're forcing an output from an input.
So yeah, right. Human feedback, get involved into prompt engineering here because you put your preference of choosing the good prompt, right? Or it would be better to have some metric to objectively evaluating the output of the model, but it's not always the case. If I'll just talk more about it after presentation, but okay. And then prompt tuning and learning is just a little bit, it's very different because you're not manually doing it, but you're basically algorithmically tuning the prompt. If you're interested in on this particular method, search p-tuning and clicking that text there, it will lead to some like a blog page or instruction page to give you more information. So as an analogy, okay, here's a father-like Asian man here. I want to make him look better. There are two ways. Either give him like a better like outfit, he looks better on the right, or I send him to a gym and make him better and muscular and But like as you see, like he still has belly, he still has like some stuff, but like he looks a lot better on the right hand side, right? So this prompt engineering tuning can be like making different inputs and making better input so that you get better output. But reality is like nothing has changed here. So another technique is like a fine tuning. So now this focuses on model, okay? So in many cases, even like a ChatGPT or GPT-4 does not do well on like a very narrow specific task or like a very in-domain task, which means like very, if the task requires like a very high level of knowledge in one area, then they don't really do well. You will see at one point. Then what you do is you fine-tune the model, you adjust the parameters within their architectures so that they learn about it. So to do that, you need data. You also need like a right approaches because, okay, I'll explain about this more after presentation if you're interested, but like fine-tuning, this area is really big to talk about in like in 3 minutes or something. So fine-tuning, in short, is basically making your model better. So compared to the picture of the old Asian man, now I'm sending him to the gym and make him look better inside. Okay. All right. Last one is reinforcement learning from human feedback. Okay. In short, this one, it's It's basically hearing like opinions of like how people actually think about the result of the model. Good? All right. The problem of all this is it's costly. The very costly part of it is not training. It's more like you need a good quality data. This is very challenging. But like, okay, I can talk about this like an hour on this topic, but like the thing is, getting a good data is very, very challenging. So in this case, and also like a training can be complex depending on who you have in your team. That's another aspect. Going to the next one. So what would be the solution? I want to use ChatGPT. I know ChatGPT is a very well structured. They answer very good things. They do a lot of things very well. What can I keep using OpenAI ChatGPT with my own data set or my expertise, knowledge, and stuff? All you need to do is then provide more context. So here's an example to that. So recently, World Cup, FIFA draw the countries to host the World Cup 2030. If you're a soccer fan, you probably know. There are 6 countries or something that host the World Cup 2030. What I asked this question to ChatGPT just hours ago, and their response is, I don't know. Okay? The reason is they were trained with the data set that was before the drawing of World Cup 2030. They have no knowledge of it. So in this case, I just appended an article on World Cup 2030 and asked the same question. Then they gave the correct answer. So all you need to do then is giving them more information, more context. Then they'll give you proper answer. So this method is called retrieval augmented generation. So giving them more information. Then the challenge is like, how do you search the relevant information based on your prompt? So when I'm saying which countries are hosting World Cup 2030, how are you going to search the relevant information automatically from web or your own database, right? So again, the challenge in this context is no longer about how to fine-tune the model, but the challenge is like how to retrieve the relevant information. So I'll just walk through the steps of how to make this RAG work. The first thing is you put the text input into encoder. So again, what does encoder does? It generate embedding, right? What does embedding does? Embedding includes, it encapsulate the context of the text input, right? Based on that information, based on that thing, you find the most relevant information using the contextual embedding from the encoder and search through the web or search through the database. So what database would it be needed in this context? We need vector database, right? That's where vector database comes in, right? Through a vector database, you search and retrieve the relevant text and then append it to prompt appropriately and then generate the final prompt. Then you feed into the decoder model like ChatGPT or Llama. Then you get the response. Good? So this presentation is part 1. I hope, yes.
Instead of doing that, you can do what you did, which was you didn't bother with encoding it into a vector embedding.
Mm-hmm.
You just gave it an article, and you said basically summarize the article. So you jumped right to the bottom with the final prompt because you had retrieved knowledge.
Yes, in the World Cup's case, yes, you're correct.
But the problem with that is the size of your input prompt is, or your context for your input prompt is small, relatively speaking. Whereas the vector, by going through this mechanism, the vector encoding uses much less of that context.
Yes, but okay, we can talk about more details about that after presentation. I don't want to steal too much time of everybody, but yes, let's talk about it. But
This example is doing what he did automatically.
yes.
Correct.
Okay, thank you. Yeah, so if vector database is quite a new thing relative to like a traditional RDBMS thing, so it would I don't know. I think it worth like learning about it. Second thing is like I'll leave for Hartford or Atlanta in February, so I wish like somebody else can, yeah, continue this like a sequence of presentation. So let me know if you're interested to do further presentation. Thank you.